that this one works and is neater handwriting and smaller than when I was trying to do my finger in the first section. All right, so here in this section, it says find the exact value. So when you see that exact value, we're gonna have a number answer. Okay, and it's not gonna be a decimal unless it comes out to like a whole exact number. But we can leave it as a fraction, we can leave it as a radical, like with a square root in it, because that's gonna be the exact value. We don't want to type that in the calculator and get a decimal rounded. So cosine of 345. 345 degrees is not one of the angles from the unit circle that we have memorized, but we can figure out two angles from the unit circle that we do have memorized that would add to 345 degrees or subtract to 345 degrees. And you can come up with any two that you want. Okay, so let me pull up to show y'all. Oh, maybe I don't have the unit circle in that folder. Hang on one sec. There we go. All right. So remember, you on the test are going to have quadrant 1 filled in for you. So when you get it, if that's something you want to do first is fill in the rest of it, you can do that. Okay, or some of you are good enough without writing it all in, you'll be able to figure that out. So 345 degrees we know would be down here in quadrant 4 between 330 and 360. The easiest probably is just 345 because we know 300 and we know 45. So I'm going to just do that. But you could have come up with, if you can come up with other values that add or subtract to that number, that's okay too. Oh gosh, I hope this stylus works. It's not writing as well as I had hoped. Okay, so we break it down. Now it's a cosine sum identity because it's the cosine of two values being added. So you expand cosine sum, you do cosine of the first angle, cosine of the second angle, and then cosine identity, sum and difference identity is the one that you do the opposite. So this is actually going to expand to a minus instead of a plus. And then it's sine of the first angle, sine of the second angle. Okay, so when I do that, now I know those values from the unit circle. So remember at 300 degrees down here, I know cosine is the x and sine is the y. So cosine at 300 is root 3 over 2. And then at 45, both sine and cosine are root 2 over 2. This is come on, root 3 over 2 times root 2 over 2 minus, and then sine at 300 was the negative 1/2, and then root 2 over 2 at 45. So when I go ahead and multiply these, remember these radicals multiplied together would come out to be root 6. because you multiply what's underneath them. And then that's over root 4 minus. And we can go ahead and change, since it's minus a negative, that's going to change to plus. And then that would just be root 2 in the numerator over 4 in the denominator. And then you can condense that to a single fraction. So it'd be root 6 plus root 2 all together over 4, since you're adding two fractions and you have the common denominator already. That's how you can go ahead and simplify it. And we're going to leave it like that. We're not going to try and calculate that because they want the exact value. We're going to do the same thing for tangent of 15. We're going to come up with two angles on the unit circle that we know would add or subtract to 15. I'm just going to use 45 minus 30. Okay, so 45 minus 30 would give me the 15. So I'm going to do, gosh, on pens. Well, you get the idea. All right, so now you have the identities on a reference sheet. You're going to get the identities listed on the reference sheet on the test. So you'll know what this expands to. You don't have to have this part memorized. But it's tangent. Oh my gosh. Holy cow, that says tangent of the first angle. And then you keep the sign the same. This is a minus, tangent different, so we keep it a minus. Tangent of the second angle, that's supposed to be a 30. Over, and then it is 1, and then the opposite sign, so in this case plus, tangent of the first times tangent of the second. Man, that's a 30. Really bad. All right, so reminder, tangent at 45 is 1 and tangent at 30 is root 3 over 3. So at the 45, I said that's 1. And at 30, it's root 3 over 3. And then this is 1 plus, and then that is going to be 1 again times root 3 over 3, which is just root 3 over 3. We do not have to worry about trying to rationalize with a binomial denominator like that. Y'all can just stop there and leave your answer in that format. All right. Now, roll. Not too far. Okay, hang on one sec. Sorry, had to shout at my kids real fast to be quiet. Okay. On 9, it's the same concept. We want to come up with angles that would add or subtract to negative 165 that we know from the unit circle. So if they're going to subtract to give us a negative, we know that the larger number must be the negative one. So we still need to use angles that we know. Hang on one sec. Kids are, let me get them quiet real fast. Okay, sorry about that. All right, so we're trying to add to negative 165. If you need to think of it the other way around, to subtract to positive 165, and then we can just change the sign if that's easier for you. That's fine too. So you could pretty much you want to start with negative 165. There's some options for you here. If we did positive 45, like if we added 45 to that, you'd get negative 120. So you could use negative 120 and positive 45. And so you could write that as, I'm recording a video. No, go in the other room. I will be there. Shh. Stop. My kids can all hear you right now. Go. Apparently they didn't understand what be quiet meant. Okay. So what did we say? We said we're going to use 45 and 120. Okay, and both would have to be negative. If you wanted to get different numbers so that one was positive and one was negative, you could do that too. Okay, that doesn't really matter. You're going to end up with the same answer at the end as long as you do that correctly. But I know 45 and 120 add to 165. So if I just make them both negative, then it'll add to negative 165. Now, when you're doing this with negatives, you have to remember that when you count a negative number, you're going clockwise. So negative 120 actually puts you down here at positive 240 in quadrant 3. And negative 45 actually puts you down here at negative 315 in quadrant 4. So those are the ordered pair we're going to look at. Okay. So sine expands. The sine, and this is going to be, you've got a choice here. You can think of this as plus a negative angle, or we could just think of this as minus a positive angle, and that might actually be easier for y'all. So we'll do it that way. We'll do minus positive 120. So the sine expands to sine of the first angle, so not sine of negative 45, and then cosine of the second angle, which is 120. And then you keep the plus or minus here the same. So that is minus. And then sine of the second angle times cosine of the first, which is the negative 45. All right, so now we only have to think of the negative 45, which would be the same as positive 315. Okay, so that's at the root 2 over 2, negative root 2 over 2. So cosine is positive, sine is negative. And then we can use positive 120, which is up in quadrant 2, at negative 1/2 root 3 over 2. All right, so at negative 45, sine is negative. Oh, come on. There you go. Root 2 over 2. And then at 120, cosine is negative 1/2. We've got a minus sign, and then sine at 120 is root 3 over 2. And cosine at negative 45 is positive root 2 over 2. So when I condense this, I'll try and make this fit on this screen with this stylus that won't write small. So we end up with a positive root 2 over 4 here. Minus, and then we end up with a root 6 over 4 here. So then that could be condensed to root 2 minus root 6 all together over 4. It's condensed down to a single fraction. All right, now number 10 is actually a little easier. This is not sum or difference. They give you one trig value and ask you for another. So as long as you know the relationship between the two trig values, this one's easy. Secant and cosine are reciprocals of each other. Reciprocal simply means flip the fraction. So if you know those reciprocals and you know one of those trig functions, that goes back to what we did up here. If my thing will go this way. Back up here in the first section, like on number 2, we got it down to isolate cosecant. But we don't know where cosecant is what. So we do the reciprocal and say, okay, well, if cosecant's root 2, that means sine is root 2 over 2. So it's that same relationship we're finding down here. So if we know cosine is 2/3, then secant is 3/2. You simply flip it the fraction because those two are reciprocals. So you find the reciprocal of that value. Now, if when you do the reciprocal, whatever the numbers happen to be, if it reduces, you would want to reduce it. Or if it puts a radical in the denominator, you'd want to rationalize it. Okay, but the concept really is, it's just the reciprocal, just flip the fraction. All right, let's go on. Oh, I thought that would scroll. There we go. All right, now this is still using a lot of the sum and difference identities, but there it says write the expression. So we're working backwards now. We're condensing these down to a single trig expression. So it's just going to be sine, cosine, or tangent of an angle. So this is just going to be, am I using sine, cosine, or tangent? And is it the sum or the difference? And can I condense those? Like what's the first angle and the second angle? Okay, when the cosines are together and the sines are together, remember that's cosine. And you don't actually even have to remember that. I'm giving you the identities on the reference sheet. So just look at it and see, oh, when the cosines are together and when the sines are together, that's cosine. So I know this is cosine. Oh my gosh. Okay, and then look at the sign in the middle. In this case, it's minus. And look at your reference sheet. Remember, when it's cosine, it's the opposite. So this is actually going to be a cosine sum identity. So this is going to be cosine of, and then it's your first angle and your second angle. So we just got through on another problem saying 45 and 120 was 165. So my final answer here is simply cosine of 165 degrees. That's all I needed to do here. I can't find the exact value without a calculator. Going backward like that, I would have to input, but this one was having me go backwards to get the original expression. All right, now this one is obviously tangent, number 12. Okay, and I look at my reference sheet and I know that I keep the sign that's in the top. So this is a tangent sum identity. So I know it's tangent of one angle plus another angle. And then it's pretty easy, just look at my angles, 25 and 10. And that comes out to tangent of 35 degrees. 13 is also tangent. It's not same format. Okay, this time it is minus, and the angles are 30 and x. So all I can do is condense it to tangent of 30 minus x. I can't do anything further since one of those is a variable that I don't know. That's as far as I can take it. All right. 14. The cosines are together again. And the sines are together, so I know it's cosine again. And I know I keep the opposites sign, so that's a plus, because it's the opposite of what I see there for when it's cosine. And my two angles are pi sevenths and pi fifths. Okay, fractions, you need to be able to add fractions so you get a common denominator. So if you need to do this off to the side, you can, or you can do it in your head. But 7 times 5 is 35. So this would become 5 pi over 35, and this would become 7 pi over 35. So that's 12 pi over 35. And that's as far as we can take that one. Now this next section is very similar, but it goes back to saying, asking, or saying, rolling again. There we go. Back to saying exact value. So we're going to do the same thing, but when we condense it this time, it's going to be a value from the unit circle that we do now. Okay, so cosine together again, sine together again. So this is cosine. The angles are 70 and 20. And I do the opposite sign, so that's plus. So 70 plus 20 is 90. So now this is cosine of 90 degrees, which we know, well, you should know, cosine at 90 degrees, that's the x at 90, is simply 0. You can look at your unit circle to get that. All right, on 16, we do the same thing. This time, sine and cosine aren't together. Notice they're mixed. There's sine and cosine on the left, cosine and sine on the right. So this one is a sine sum or difference identity. Sine keeps its sign, so it stays plus. So this is sine of two angles being added. So this is 15 and 75. So that is 78 and also 90. So this one wants sine at 90 degrees. So sine is the y value at 90 degrees, and it is simply 1. Okay. 17 is back to tangent. Okay, we keep the sign that's on top. And so we're doing tangent of, and then the angles are 48 and 12, 50, 60. So tangent of 60, should know from your unit circle. If you don't know it, you can refer back to it. Tangent at 60 degrees is root 3. All right, 18, we're going to condense again. Cosines together and sines together. So this one's back to cosine. And it is sum. And it's another one that is 3 pi halves and pi. Now, technically, you don't have to do these this way. If these are angles that you actually know from the unit circle already, like 3 pi halves and pi, you could just plug all 4 of those values in and evaluate. But I still think it's easier to condense it this way first. But so if I think about this, 3 pi halves is down here, it's at the bottom. It's 3/4 of the way around the circle. Okay, if I go another pi, which is half a circle, that's going to put me up at the top. Okay, so they're looking for cosine up there at the top. Okay, if you need to know what the value is when I say up at the top, then 3 pi halves, you could convert this to 2 pi halves so that it has a common denominator. So you're talking about 5 pi halves. And again, that would be going around the circle 1 full time and a quarter, because 2 pi is a full circle. That'd be 4 halves. You're going 1 more half. So you're up at the top of the circle at the pi halves, or the 90 degrees would be coterminal to this, and cosine there is 0. All right. I'm going to go ahead and do 19 and 20 in this video, then I'll stop and we'll do the rest in a separate video. But this is still sum and difference, so I'll keep going here. So sum and difference here, I'm going to expand so that I can evaluate this, simplify this. That's cosine of the first, cosine of the second, and then the opposite sign. So that becomes plus. And then sine of the first, sine of the second. Now, 3 pi halves, that's the bottom of the unit circle. We know the value down there. Cosine is 0, sine is -1. So if this right here, this is a 0, 0 times anything is 0. So that whole expression is gone. I don't need it. And then we know that sine at 3 pi halves is a -1. So I'm just multiplying -1 times sine of x. And that's all that's left here. So it just comes out to negative sine of x. So that's simplified down to a trig expression. We're going to do the same thing over here on 20. We already have it expanded. So like the first step's already done for us. So I'm going to go ahead and just say, okay, well, at pi halves, that's one of the angles I know. Up here at the top of the unit circle, I know cosine is 0 and sine is 1. So sine at pi halves is a 1, cosine at pi halves is a 0. So this whole side is gone because 0 times anything is 0, drop it. So over here, I just end up with 1 times cosine y. So this is simply cosine of y. And that's as far as we have to take that. All right, I'm going to stop this video here. If you have questions on the first 6, that was in a separate video, and then questions on the rest will be in a separate video as well.